All right, we're at the review for Unit 12, quadratic functions and quadratic equations. So the test will be posted tomorrow. All right, you'll have till Sunday to do the test. Please have a scratch paper that you save and put your name on. So, is a function linear or quadratic? Quadratic functions have x squared in them. So this is a quadratic function. This is linear. It would make a straight line. The shape of a quadratic is a parabola. This parabola faces down because the coefficient, right, this is ax squared plus bx plus c. If a is negative, the parabola faces down. This is linear. Its y-intercept is 0, 7, right? That's how you write y-intercepts if asked, not 7. Its slope is -5, but I didn't ask you that here. The y-intercept of this one is in the exact same spot as a linear function. It is 0, -4. So this is a quadratic function. This shape is called a parabola. It is just exactly how it sounds spelled. And its roots are the x-intercepts. So find the root or roots of this quadratic function. The root is x equals 4. Now on the test, just type the number. Don't type the braces. It says that in the test, but just to reinforce that. So the root of that quadratic function is 1 root at 4, right? If I say what's the x-intercept, which I won't on the test, I would say 4, 0. This one over here has no roots, right? It does not cross the x-axis. The vertex is the highest or lowest point. Its coordinates, in this case, are 1, 8 with parentheses. The roots are located at x equals 1 and x equals -3. On the test, I'm going to ask you to put the lower one first. I could have, that way I didn't have to have multiple answers for each one. So you have to know that -3 is lower than 1. The y-intercept is 0, 6. The line down the middle of a parabola is called the axis of symmetry. Across the axis of symmetry is always a symmetrical point. So the symmetrical point is -2, 6. Notice the roots are also symmetrical on either side of the axis of symmetry, the same distance away from it. You should be able to look at those functions and know which one is this parabola. It's A. Why? Well, it has the correct y-intercept, but more importantly, the function has a negative coefficient for x squared. That means it's upside down. So it can't be the other one. So you're going to find the roots of this function. If it doesn't say which method to use, you always want to use factoring. So we have to make it equal to 0. You need to know that we're using the zero product property to do this, right? I got to spell property correctly. So factors of this are x plus 5 and x plus 1. So the roots will be located at -5 and -1. And -5 is lower, so I'm going to put that one first. The y-intercept of that function is at 0, 5. The the axis of symmetry and the vertex. So let's draw a sketch of this function. So there's the y-axis, there's the x-axis. It has a y-intercept of 0, 5, 2, 3, 4, 5. All right. The roots are at -5, 1, 2, 3, 4, -5, and -1. We also know it opens up because it's a positive number in front of x squared. We also know where the axis of symmetry is. It's right because the roots are symmetrical. So the axis of symmetry is located at x equals -3, right? That's midway between -5 and -1, the roots. So the vertex must be where f of -3 is. So we have to do f of -3. -3 squared with parentheses around it, plus 6 times -3, plus 5. -3 squared is 9. 6 times -3, -18, plus 5. Order of operations, 9 minus 18, -9. -9 plus 5 equals -4. Therefore, the axis of symmetry, the vertex, the lowest point in this case, is at -3, 1, 2, 3, -4. That is the vertex. We also know that there's got to be a symmetrical point, right? This is 2. This is 3 over there, so one more over that way. There's a symmetrical point there. Goes through the roots, down to the vertex, back up, through the y-intercept, and there's a sketch of our parabola. Notice I didn't need to use -b over 2a to find the axis of symmetry since I knew the roots. But you can always do that, right? B was 6, so -6 over 2, right? -b over 2a gets you the x coordinate of the vertex. Right, to solve this equation, right, we have to use the zero product property. So this has to equal 0, right? It equals -6. We have to get rid of that, both sides. Now we're going to factor that. So we have -1, x minus 6. But those aren't the solutions. The solutions are x equals 1 and x equals 6. And on the test, we're not using the braces. There'll be a spot where you put the first one, 1, and then there'll be another spot where you'll put the second one, 6, just like that. Same thing here. Right? -10 minus 11. So the solutions are x equals 2, but let's do the smaller one. I think this other one is going to be smaller. Let's see. 5x minus 1 equals 0, right? Right, the zero product property. They have to equal 0 for their answer to be 0. 5x equals 1, divide by 5. Yeah, the other answer is positive 1/5. Factor completely is a dead giveaway that you need to remove a common factor. Notice, you can divide both sides by 3 and it just goes away. This looks like it's going to be a perfect square trinomial to me. And so there is one solution, x equals -3. So the key to this is the ground is at height 0. H stands for height as a function of time. So the ground is at 0. And so we're going to solve this equation to find out when the ball will hit the ground. We're going to remove a common factor. So we're going to remove a -5. we're going to remove a negative 5t, my fault, and we have t minus 10. So to make negative, there's two factors here. Negative 5t can equal 0, t minus 10 equals 0. So this ball was shot in the air, so it took 10 seconds before it hit the ground. This one over here is where it started, right? You'll get that answer, but that's not what we need. We know it started at 0 and took 10 seconds to get back to the ground. Right? So we're going to work backwards here to figure out the quadratic function, a quadratic function. So 4 must go with x minus 4. That's what will make that equal 0. The denominator goes first, so it's 2x plus 1 to make a negative 1/2, right? And if you FOIL that, right, we will find the quadratic function. 2x times x, 2x squared. 2x times negative 4, negative 8x. 1 times x, x, so negative 7x. 1 times negative 4, negative 4. And we want to write a function, so f of x equals 2x squared minus 7x minus 4 is the linear function that has those roots. If you multiply that times 1/4, as in 1/4 f of x, you would do 1/4 times 2, which is 1/2. 1/4 times negative 7, negative 7/4 x. 1/4 times negative 4, negative 1. Yeah, that looks weird because we don't usually have fraction coefficients. But that is another function that has the exact same roots. It is just vertically shrunk. Fractions vertically shrink the linear function, the quadratic function, and whole numbers, if I multiply it by 5, that would stretch it. But both of these, this one here and the one we started with, have the same roots, negative 1/2 and positive 4, 2, 3, 4. All right, and it opens up. And you can see there's the y-intercept at 0. Well, so one of them looks like this, right? And then the other one is shrunk. Yeah, so this one, let's be a little less swift. The top one had 0, negative 4 as its y-intercept. So it looks something like that. And then the shrunk one has 0, negative 1. It has the same roots. I'm not going to bother to find all the other points, but it's shrunk. So now it says use the quadratic formula. Typically, you would do that if the roots are irrational. You need to memorize the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So x equals, b here is 5, so negative 5 plus or minus the square root. B squared is 25 minus 4. A is negative 2. C is negative 1. All over 2 times negative 2. So x equals negative 5 plus or minus the square root of 25. 4 times negative 2, negative 8. Negative 8 times negative 1, positive 8. So it's 25 minus 8 over negative 4. X equals negative 5 plus or minus 25 minus 8, I believe, is 17. And so those are the two roots, right? There's a plus square root of 17 minus square root of 17 for that linear function, quadratic function. Let's do that again. Negative b, so 3 here, because it's already negative, plus or minus the square root of b squared, 9, minus 4. A is 5, c is 1, all over 2 times 5. So we get x equals 3 plus or minus the square root of 9 minus 20. Uh-oh. 9 minus 20 is a negative number. That means this is an imaginary answer. And so that means there are no real roots because you have an imaginary number in there. So the number of no real roots, or you would say the number of solutions is none if it was an equation. X equals negative b. B is negative 4, so positive 4 plus or minus the square root of b squared, negative 4 squared 16, minus 4 times a, which is 4, times c, which is 1, all over 2 times 4. X equals 4 plus or minus 16 minus 16 is 0. So we get x equals 4 over 8, which equals 1/2. So the root would be at 1/2. If it was an equation, you'd say the solution is 1/2. And so there is one root or one solution. Completing the square, our last lesson. So you just have to know how to do this, right? You have to make that a perfect square trinomial. That means this number is not the right number for a perfect square trinomial. So we have x squared plus 6x, and we leave a space for the perfect square. The perfect square is b divided by 2 squared. So 6 divided by 2 is 3. 3 squared is 9. We're adding 9 to both sides. Forgetting that 9 is the single most common mistake. Right? We're forcing that to be a perfect square trinomial so we can get x plus 3 squared there equals 29. Take the square root of both sides. It's really the positive and negative square roots of both sides. So we get x plus 3 equals positive and negative square root of 29. Subtract 3 from both sides. There are two roots here. They're just irrational. At negative 3 plus the square root of 29 and negative 3 minus the square root of 29. So it says factor completely. I got a negative coefficient. Let's take out a negative 7. X squared minus 2x plus 1 equals 0. What's great is you can divide both sides by negative 7 and that just goes away. So the factors here are x minus 1 and x minus 1. So there is one value of x. This was not a function, so it's a solution, not a root. But that one solution is x equals 1. Oh, there's my college graduation picture. I think I grew up a lot in the 4 years from high school. To find an area, it's length times width. So x times 2x plus 5, and we said the area was 33. Distributive property, x times 2x, 2x squared, x times 5, 5x, right? To solve these, we need the zero product property. So it has to equal 0. So we got to do that. So we get 2x squared plus 5x minus 33 equals 0. We have to factor this. This looks like it's going to be hard to factor, but I don't think so, because 33 is probably 3 and 11. Let's see. So let's do 11 there, 3 there, plus there, minus there. Yeah, 11x in the middle, 2x minus 6x. Yeah, that makes 5x. So the solutions to this are x equals 3, right? Because that'll make x minus 3 equal to 0. And what's 2x plus 11 going to equal to 0? Subtract 11 from both sides. 2x equals negative 11. Divide by, well, you get a negative number. Well, x can't be a negative number because the side of here can't be negative 11/2. So the only possible value of x is 3. Take the test when you're ready. It's online. It grades it automatically. Right after you take the test, you should be able to see your grade in Schoology.